Hello, Amir.
Hello, how are you?
Not bad. How are you?
I'm fine, thank you for asking. I am unable to turn on my video.
Oh, okay. We'll
Mhm.
figure it out.
Sure. It says
Okay,
that you cannot start your video because the host has stopped it.
okay, that's strange. I'll figure that out for wait a moment, sorry.
And no
Uh,
problem.
I can share, but I'm not sure why you can't. What does it say?
So when I click on this video, it says you cannot start your video because the host has stopped it.
Hmm, because it says I have who can share, it says host and panelists, and you are a panelist here, but I'm not sure why you can't do it.
Mhm. Okay.
Oh, okay, let's just restart it. Okay,
Okay.
try now. Can you do it now?
Okay. No, I still get the same message.
Okay, I have no idea what to do. Okay, I'll give you a host so you can try now. Okay.
Sure.
Okay, you are a host now. Try. You can
Mm.
share now.
Yes,
Uh,
I can.
It worked normally for the past three times, but now it doesn't work for some reason. But yeah, okay.
Okay. Yeah. So that's fine. For now, you can take this. You can become a host, and once we start, then you can pass it to me.
No, it's perfectly fine. It's important that I can present you to other attendees. Other than that, you can be host, no problem.
Okay. Thank you for that.
Yeah, you're welcome. Yeah, we won't start at 3:15 sharp. We'll wait a few more minutes just to see if any more people will join.
Sure. We can wait for some time.
Uh, Now I can't turn on my camera.
Okay.
Unbelievable.
So you become a host for a minute, you turn on
Yeah,
your camera, and
yeah,
then pass on to me.
yeah. Really stupid for me turning my camera off for a minute.
No problem.
But it wasn't like this for the past three webinars. I'm not sure what's happening. Okay. Yeah, perfect.
Yeah, perfect. My camera is also on, so
Yeah, but okay. This is that. Jeez. Yeah, we'll start in a minute or two.
sure, no problem.
Okay, we can start. Well, hello again, everybody. Thank you for staying this late with us. This is our last tutorial for the day, and our last tutor is Amir. Amir is data scientist at T Systems, and he will tell us more about how to build a RAG system using Llama 3.1. So, as always, if you have any questions, you can write your questions in Q&A chat after the webinar ends. Well, when the session ends, we'll have 15 more minutes to answer all your questions. So good luck to everybody, enjoy, and I'll give my words to Amir now.
Thank you for your introduction. Good afternoon, everyone. And let me share my screen first, then I'll start with my introduction. So my name is Amir Siddiqui. I work as a data scientist with T Systems India. And I also have a YouTube channel on data science where I talk about machine learning, LLMs, and the channel name is StatsFire. You can check it out. So today's topic is about building a RAG pipeline using Llama 3.1. So you all must have heard about this new LLM from Meta, which is Llama 3.1. We will go through theory and then also a quick hands-on. So that will take only few minutes, and you will learn how you can create LLM easily with free API keys. So let's start this session. Let's have a look at the agenda, what we are going to see. So we are going to cover first some basics of NLP and information retrieval, then introduction to RAG, the RAG process, introduction to Llama 3.1 model. Then we will be creating this RAG pipeline using Llama Index, a framework to develop LLM, and why we are using Llama Index, what are the benefits of Llama Index, and a hands-on example to create RAG pipeline using Llama Index and Llama 3.1 LLM. So first, let's have an overview of NLP. NLP is natural language processing, and it is the base of any large language models, because you might have heard about encoder, decoders, or some other models that we use in NLP, like RNN, recurrent neural network, then LSTM, long short-term memory. So these are the basics of RAG. If before you get into the LLM, you must be aware of these NLP concepts. These are very helpful, and these are the base of all the LLMs that you see nowadays. So when you have your text data, before you even pass it to your model, you have to do some pre-processing on that text, and that can be done using NLP techniques. So there are various packages available in Python for NLP. For example, you have NLTK, Spacey, and there are other packages as well. So using these packages, you can pre-process your text data, you can do cleaning, you can remove stop words. So stop words are some of the words which are frequently occur in the document, and they are of no use for the model. For example, the, a, and. So these are the words that are not useful for your model. So we remove these words. So they are stop words. Then we do some stemming, lemmatization. So there are different types of words. We have to get those words into root words so that all the words are having same meaning. For example, you have a word run, then you will have running. So you will just, uh, cut the other part of the word and bring it to the root word run. So that is one of the technique of stemming and lemmatization. So both of them are used to get the root word, and they have some um, similarities and also some distinct function between them. So you can use those functions to get your root words. So you have to prepare your data using NLP techniques. And once you have prepared your data set, then you can use this for language translation, text classification, sentiment analysis, and text generation. So these are some of the use cases that you can do with NLP. So this is the base of your your LLMs. And now, when we talk about RAG, so in RAG, we have two concepts. One is information retrieval, and the second one is generation. So we already had this technique and we have been using this, but earlier the approach was different. So earlier, what we used to do is we used to obtain, relevant information from collection based on user queries, and the method used to get this information was about keyword matching. We used to match these keyword where documents they contain some specific keywords that are similar. We used to do some Boolean queries. Then we use logical operators like and, or, not. So we used to do these. We used to do these things to get our information, or we used to retrieve information this way. So this was about, how we used to do this traditional retrieval approach. But now we have improve this retrieval information, and now we use embeddings, so that is more efficient and we get even much better results when we use embeddings to retrieve information from documents. And this is covered in RAG. So this is the overview of NLP, why we use it, and what is the use of NLP in LLM itself, and also about this information retrieval, how we used to do it earlier. Now let's talk about RAG, which is the advanced form and what we see today everywhere. So everyone is talking about RAG. Every company wants to build their own RAGs because they have their own documents that they want to access. So instead of going through all the documents, maybe a document containing 500 pages or 1000 pages. So if you want to get some information from that document, then you have to read that entire document. You have to go through each and every page because you don't know what information is on what page. So you have to go through, and it will take a lot of time for you to go through those documents and get the information. So this is where a rack comes, where you can use all your documents from your organization, or maybe even if you have a book that you want to read, and you just want to, you don't want to read that entire book, but you want to get some context, some information, what is the book is about, who is the author, how many chapters there are there, what is the story, what is the conclusion. So you can create a simple rag in few minutes, and then you can just upload your PDF book as a knowledge base, and you can start querying. So you don't have to read that entire 500 or 300 or 1000 pages of book. You can simply upload it and start querying. You will get all the answers. So talking about RAG, so the full form of RAG is retrieval augmented generation. So it is a model where we have two important process. The first one is retrieval and the second one is generation. So the retrieval searches for reliable documents from a large corpus based on a given query. So what do you mean by large corpus here? So whatever document you have, maybe you have a PDF file or a text file, or you have some information in JSON format or any other format. So whatever data you have is known as corpus here. So what you do, you will upload your data, and that will become your corpus. And now you will write a query because you want to get some information from that data. So that is a query. So this is the first part where you are uploading your document and you are creating a corpus, and then you are asking question based on the document. Now the second part is generation. So the generation component creates a response that will have information from these retrieved documents. So once you ask question about the document that you have uploaded, now RAG will generate response for you. So first, it will retrieve all the components based on your question, and then second, it will generate response based on that. So this is retrieval augmented generation. So here you have retrieval component where you will ask query to the document you have uploaded, and generation is where the model will generate a response based on your query. Now, how this RAG works. So you have this documents, you write the query, and then you ask some questions. So it works on some embeddings. It uses embeddings. It will use a vector database. It will vectorize your documents before it passes to the model, because you know that machine learning models or deep learning models, they don't understand text, they only understand numbers. So before you even pass this text to your model, you have to convert them into embeddings. You have to create a vectors, and that's how this RAG works. Now let's break down this entire RAG into different steps. So the first one, let's even go in detail about this retrieval process. So you have in retrieval, you have input query, document retrieval, and ranking. So input query is about the question that you ask. Then the second step is document retrieval. Now you have given or you have uploaded a 500 page of document. So you know that what whatever question you are asking is going to be on some page, not in the entire 500 page. So when you ask a question, it will go and search your document and retrieve the page where the answer is present. So wherever it sees that the answer is present, it will retrieve all those documents. Maybe you are asking some information about author, about a book, and when you ask this query, the retrieval process will go and check entire 500 pages and see wherever there is something mentioned about the author, it will fetch all those document. So it will retrieve all those documents. Now it retrieves, let's say, 15 pages where the information about the author is present that you want it. Now what will happen, because now it has 15 pages, but you want an exact answer. You don't want everything. You just want a specific answer. So now the third step is ranking. So out of all these 15 retrieved document, which one is the most important, or which one is the most relevant to the question that you have asked? So that is the part of ranking. So first you will write a query. Second, it will retrieve all the places where the answer is present. And third, it will rank all the answers. And based on your query, it will give you the most relevant answer. So this is step one about retrieval. Now the step two is contextualization. Now what happens when it finds the answer in 15 documents? It will now start ranking this document. It will say, okay, out of this 15 document, this seventh number document will come on the first position. The 10th one will go on the second one. The second one, the third one will go on 10th number. So based on the query that you have asked, it will try to rank the documents, the answers for you, and then it will give you the most relevant answer. Now, contextual embeddings. So what happens when you upload your documents? We have to convert the documents into embeddings, and embeddings are nothing but the numerical representation of your text. So now whatever you see here, text, maybe if you read this first paragraph, the top ranked documents are selected based on their relevant scores. These documents will be used to provide context for generating the response. Now we have this text, but before we pass it to the model, we have to convert this into numbers, and converting this text into a number is known as embeddings. So you will have numbers for all this text. So that is contextual embedding. So have this uh, we have this sentences, or we have paragraphs. So it tries to capture the context of that paragraph, and based on the context it will create embeddings. It will not randomly create embeddings. So it will not say, let's say, let's give the as number one, top ranked as number two. No, it will not give this random numbers or random embeddings. It will understand the paragraph. It will try to understand the context of this paragraph, and based on this context it will give embeddings. So that is contextual embeddings. Now the step three comes generation. So you have done your first step. Now how the model is giving you the answer? So when you see that you are typing something in the chat GPT, you ask some question. I am a beginner. I want to learn Python. Please tell me step by step how I can learn Python. So that is your retrieval part. You are asking query to that chat GPT. When you get the response from chat GPT, that is known as generation. So ChatGPT will generate answers for you based on the question that you have asked. So in RAG, that comes the step three, where the model will generate answers for you based on the question that you have asked. So it says that combining query and context. So when you ask a question to ChatGPT, it just didn't, it doesn't just go by word that the user is asking uh, what is Python. It will take the entire context. What context, on what context the user is asking me question. So it will understand the context. You are writing, I am a beginner, I want to learn Python. So it will understand the entire context that, okay, you are a beginner and you want to learn Python. It will just not go randomly that you want to learn Python, you are beginner. No. So it will understand the context and then it will generate response for you. So that is the process of combining your query and context. Then once it understand the context, then it will generate a response for you. That is, it will give you answers. So what you use ChatGPT, that is also a kind of RAG. So we have different models that can be used to create RAG, and such as GPT-3, which is used by ChatGPT, then Llama 3.1 from Meta. Then we have Mistral AI, that is also one of a very good model, Gemini from Google. So these are some of the LLMs. So there are many thousands of LLMs, and these are some examples that I'm giving. So these are the LLM models that you can use to generate response to your query. Now, once you have generated your response, what happens when you get a response? Maybe some of the answers are not relevant. Sometimes you feel that what ChatGPT is giving you is maybe repetitive, or the answer that you are looking for is not given by ChatGPT. So in that case, post processing happens. Whatever answer is given by these ChatGPT or LLM, that will be refined through post processing steps to ensure that when you ask this question next time, it will learn from its past response and your past queries, whether you were satisfied with the answer, and it will learn from this process. And when next time you will ask the same question, you will get even a better response. So that is post processing, where the model will again learn from the response and how you have reply to that response, whether you are happy with that or you are not. Maybe you sometimes you reply that no, I don't want this answer, I'm looking for this one. So you get a better response. So this is how that LLM learns. It will give you answers, then you will reply whether you are happy or not, and then it will try to improve its response. And next time when you will ask the same question, you will get a better response. So this is step 3 about generation. And then the step 4 is about evaluation and feedback. So once you have developed your LLM and you have asked some questions and you got answers, now you want to evaluate whether the answers that you are getting is correct or not, how your RAG is performing. So in machine learning also we have something, evaluation metrics. So if you talk about linear regression, there we have RMSE, root mean square error, then we have MSE, mean square error. If you talk about classification algorithms, so there you have confusion metrics, you have accuracy, precision, recall, F1 score, AUC. So these are the metrics that you use for linear regression and classification problem. Now this is LLM. You cannot use the same metrics here as well. And here you will have some different evaluation metrics that you have to use, and you have to check whether the response which is generated by the LLM is actually correct or not, or how accurate are your response. So you can use some of the metrics like BLU score, then there are other metrics as well, and there are other open source evaluation platform which you can use, for example Phoenix, then Ragas. So there are different metrics that are available that you can use to evaluate the performance of your RAG pipeline, whether it is working, whether it is giving you a good response, an expected response or not. So you will be evaluating your RAG using these metrics. Then we have this feedback loop where we talk about the fine tuning. So whatever answers you are getting, you are not satisfied with that. So you have to fine tune your model. Maybe you will pass some additional data. Maybe the model is not trained on enough of data, and that is why the model is unable to give you good response. So you can fine tune it. Maybe you can also some change some parameters. You can adjust those parameters to make sure that the model works best with your documents. So we have different domains. We have banking, finance, healthcare, retail. So for every domain, we can train our RAG pipeline. So our RAG pipeline will be domain specific in that case, and it will give you all the answer related to that domain, maybe retail, healthcare, finance, banking, and so on. So if we look at this diagram to understand how this RAG works, so There are 4 steps that involves in this, and whatever we have learned so far, or whatever we have seen so far, that has been summarized into this picture so you can understand it even better. So there are 4 steps. First, you have to write a query. That means you will submit a query. You will ask some question like how you ask a question to ChatGPT. Once you ask the question, then the RAG will go and check for all the relevant documents where the answer is present. So maybe the answer is present in 10 or 15 documents, but the actual answer will be in 1 page or maybe in 2 page, not in all the 10 or 15 pages, but there will be some mentioning of that question in those 10 to 15 pages. So it will go and retrieve all those pages. Now, once you have those pages, so it will do the ranking where it will rank the document, and it will say that the document at rank 1 is the most relevant for your question, and this document has the answer that you are looking for. So that will do the document processing, and then it will rank your document. And once you have that relevant document, it will generate the response. So it will generate the response based on the question that you asked to your RAG. So these are the 4 key steps that you will perform when you are creating your RAG. So far we have seen what is a RAG pipeline and what are the steps involved in that. And let's just have a very brief introduction about this Meta's Llama 3.1 LLM model. So it is a very powerful large language model, and you must have heard about it, Llama 3.1. So it has different versions. So you will have this in 8 billion parameters. Then we have in 17 billion parameters and also 4.0405 billion parameters. There are different versions of Llama 3.1, and you can use this model locally. If you want to use it locally, you have to download a framework, open source framework known as Llama. But if you want to use it locally, then your machine should be very um, very hard. So it must have a good configuration. It must have a good RAM and hard drive. So before you even download that Olama, just make sure that you have a very powerful machine. Otherwise, the second option is you can access Llama 3.1 using APIs. And I'm going to show you in hands-on how you can use this free API and use this Llama 3.1. Now, what is Llama Index? So as I have said in the introduction that we will be using Llama Index framework to create this RAG pipeline. So if you know about machine learning, so if you want to create some models in Python like linear regression, logistic regression, random forest, decision tree, you use a framework scikit-learn. So scikit-learn helps you with machine learning. If you want to use some deep learning models like neural networks, so what you use TensorFlow or PyTorch or any other library. So those are for deep learning. Now you want to create LLM. So what framework you are going to use? So for LLM, there are 2 frameworks. One is Llama Index and the other one is LangChain. So you can use either. Both are same. There are some minor differences that you will see, but you can use any of them. And when you talk about RAG, so Llama Index is better than LangChain. Most of the companies, most of the people, they prefer Llama Index because when you are creating RAG pipeline, it gives you even much better result. It has more functionality than LangChain. So that is why it is most preferred, but LangChain is also a very good framework. So this Llama Index can be used for creating LLMs. And in Llama Index, there are some steps. So if you see here, these are the steps. The first one is data ingestion. So in this step, you have to upload your document. Maybe you have a PDF file, text file, JSON file, or maybe you want to get the data from database, maybe SQL, NoSQL, or you want to get data from API. So you can get the data from anywhere. It is not limited to just PDF or maybe just text file or JSON. No, you can get data from anywhere, documents, database, API, anywhere. The second part that comes is indexing. So if you are aware of this concept in SQL, if you want to optimize your query performance, you want to get results faster, so you have to index your database. So you in indexing, what do you do is you create numbers. So it becomes very easy for you to retrieve the results when you are writing complex queries. So indexing is nothing but it is same here. You will create index for your data, and that will help you to even faster retrieval of the information that you are looking for. Then comes the query part. So here you will ask a query to your RAG, and then comes the response generation. Then the RAG will give you a response. So it will generate an answer based on your query. So these are the things that we can do using Llama Index. And it is an open source framework. It is totally free. You don't have to pay anything. You can just go and install this library, pip install Llama Index, and you can start using it. So it is an open source free framework. Now, what are the benefits of using Llama Index? So some of the benefits are you can use it to create chatbots and questionnaire answering system. So questionnaire answering system is nothing but RAG. So you can use this Llama Index for creating chatbots or Q&A, document Q&A or RAG. Then whatever LLM model you get, so you have this GPT or Gemini, Llama 3.1. So whatever LLMs you have, they are trained on publicly available data sets. So the answer that you get from ChatGPT is because all the information that are available on the internet, which are free. So the ChatGPT model is trained on all those data set. And that is the reason when you ask something about maybe a president of a country or a, a capital of a city or a country. So you get all this information because these models are trained on this publicly available data set. Now, if you want to train these LLMs on your data set, so you can even do that. And as I've said that you can do it for domain specific as well. So if your company is doing business in telecom, so you can train your data on this train your LLM on this telecom data set so that when you ask question, you will get response about the telecom. The other benefits is you can enhance the performance. So once you have some base model ready, you can always enhance it. You can fine tune it. You can play around with the parameters, or you can even pass more documents to get better results. And there are so many use cases, and it is very easy for a beginner to start with. And if you go on the official website of this Llama Index, you will get a lot of information how you can start as a beginner, and it is very easy to start with. And once you start, you can create advanced RAG pipelines, chatbots, agents. So there is also something called as agents, so where agents will go and get information for you. So you have to create agents, and then it will just go on these different websites and get the information for you. Now, these are the steps that we do in the Llama Index when we create our RAG pipeline. So we upload our document, we create index for it. Then from that index, we will write query and we will get the information or the answer from our RAG pipeline. Now, what we are going to do is we will create RAG using Llama 3.1, which is a very good model. It is one of the best model in the market today. So you get a really good response for whatever question you are asking. Maybe you are asking about some public data set or about your own data set. So now we will do a hands-on and we will see how we can create a RAG pipeline with Llama 3.1 LLM using framework Llama Index. So I'll open my Jupyter notebook and then I will show you all the steps. So I have my Jupyter notebook already opened here. And if I go to the end of this notebook, so you will see we have very few steps, and using these few steps, you can create your own LLMs with your own documents. So right now you might be having some documents in your computer, and after this session, you can create your own RAG pipeline and you can get information and you will really enjoy it. So the first thing that we have to do is we will be using this Llama 3.1 using API keys. So as I said, there are two ways. The first one is you can use this Llama 3.1 LLM locally using Olama, but for that you must have a very good machine, a very good performance of that machine, at least 16 GB of RAM, 1 TB of your SSD. So that is difficult in many cases. Not everyone has that. So the best part is you use some API keys and from there you can access this. So I will show you how you can create an API key for free in just 2 minutes. You will just take, it will only take 2 minutes. You just need to have one Gmail ID account. If you have a Gmail account, you can create it. So if you, let me minimize this because I am unable to switch tabs. So you have to come on this Grok Cloud. If you Google this, you just write in Google Grok Cloud and you will get the first link for this grok.com. And once you come on this page, so you have to click on this API keys and it will ask you to sign up with your Gmail. Just sign up with your Gmail. It will only take 2 minutes, not more than 2 minutes. And once you sign up, then just come on this API key and you have to click here, create API key. And then you have to give some name here. Maybe you can just write here uh, demo rag tutorial. You can just give any name, then click on submit, and this will create an API key for you. And then you have to copy it. And also make sure that you don't share this API key with anyone else. I'm going to delete this API key right after our session because this is a personal API key. You should not share it with anyone. So make sure that you use this API key and then you can delete this. So you have to copy this and you paste it somewhere and then click on done. Now, once you have used it, so you can delete this. So I'm going to delete this one because I created now. Are you sure you want to revoke the API key? And I will just click on this revoke API. So it will delete this. And if you want to create a new one, again, click on this API key and create a new one. You can create hundred or thousands of times. Don't need to worry about that. You create it, you use it, and you delete it. So you just create one API key. Now you have to import this library from Llama Index. So from llama index.llms.grok, import grok because we are going to use API key from this grok cloud. And then we are importing these two libraries. One is related to operating system OS and the second one is getPass. So getPass is when you put your API key here. So what you do, or let me show you step by step here. So I'll go here and okay. So when you come on this page, click on this documentation and Llama 3.1 models are now available. You see here, and then you click on these models Now you see this section supported models. Grok Cloud currently supports the following models. So these are the models that you can use with the help of the API key that we have generated now. So this is Distill, Whisper, English, then Gamma 2, 9 billion, then Llama 3 Grok, and then we have this Llama 3.1, 70 billion preview, Llama 3.1, 8 billion preview, and also we have other LLM models. So we are going to use this one, Llama 3.1. Now what you have to do, you come on this page and first I will execute this cell. So this will start running. Now I will execute this one. Now you have to set the environment variable and we will store the key in this Grok API key variable. So I will execute this. And now you have to put your API key here. So I will go here. This is the API key. I will copy it from here. I will put it here and then press enter. So this will store your API key and nobody can see it. Now you see dot 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 because nobody can see your API key. Then second, now next we are creating our LLM model and we want to use this Llama 3.1. So you will go here and we will use this Llama 3.1. So you have to copy this model ID, or let's say we will use this one, Llama 3.1 8 billion instant, because this is a very heavy model and this is just 8 billion parameters. So let's use this one. You can also use this one, but just for this tutorial, I'm going to use the simpler one and I will paste that Llama 3.1 model here. And then I will execute the cell here. So it has created Llama 3.1 LLM for me in just few seconds. Now I can use this LLM to generate response. Now what I'm doing is, as I've said, first we have to upload our document. So I have one sample file, which is Paul essay. So Paul is the author of this essay. And this, you can find it, this text file, you can find it on this website of Llama Index. And it has, the essay has some information. So which some, essay which is written by the author Paul, and we have just loaded this. So to load it, you have to use this simple directory reader from Llama Index. So first you will import it from llama index.core import simple directory reader, and then you will make an object of this reader and pass your text file. Then you will load it using this function load underscore data and save it in this variable documents. And then you can print this and you can see the content. So you can read some, I will read some random line from here. So here it says, I couldn't figure out what to do with it. And in retrospect, there's not much I could have done and so on. So this is the entire essay that is in the text file that I have loaded. Now the second part is we have to create embeddings because we cannot pass this text file to our LLM. We have to first convert this text into a number. So for that, we will use Hugging Face embeddings. And this is also free. You can just import this from llamaindex.embeddings.huggingface, import Hugging Face embedding. And then you will create an object of this class Hugging Face embedding. And by default, it will take the default embedding model from Hugging Face embedding, and it will be saved in this object embed underscore model. Now, once we have this embedding, we will create sentence splitter. So what is the use of this sentence splitter? So we are passing this entire document here. This is the entire document in one line. But now we want to break down this document into different sentences. So that we will be doing it with the help of sentence splitter. So this class is responsible for breaking down text into individual sentences. So instead of passing that entire text as one sentence, we will be breaking down those sentences into different sentences, and then we will pass it. So here we are importing this sentence splitter, and then we have this two parameter chunk size and chunk overlap. So this chunk size is a very important parameter. Now it says 1000. That means if you have So let's say you have this entire document, and if you if you check the length of this entire document, it might be on 3000 or 4000, all the combining all the words and sentences. So the entire document size would be around 3000, 4000, 5000, or any number which we don't know. So what we want to say, we don't want to pass that document as the entire document, but we want to pass this into chunk. We want to break down those document, and for every 1000 word, we will create one chunk. So after 1000 words, you will have a different chunk. So if there are 5000 total words in your document, so it will be converted into 5 chunks. And the second parameter is chunk overlap. So when you break down a document, some of the information from one document or one chunk will also have overlapping information in the other one. So we want to use the information from both the chunks. So we use this parameter chunk overlap. And here also, so both of these parameters, you can give different number, and then you will try and check which number is giving you a better result. So when you will ask query, you will get a response. You will see whether the response that you are getting is correct or not. And if you see your response are not really good, so you will change the chunk size. So in that case, you have to increase and decrease both. You will try to increase and decrease this chunk size and also this chunk overlap. And then again ask question and again see whether you are getting a good response or not. So this plays a very important role when you are retrieving or when you are asking question to your LLM. Now, once we have created this chunk, the next part comes to create vector. And then we can also, after converting these chunks into vector, we can even store this vector into a database. So for tabular data, we use SQL, and for storing vector, we use vector store or vector database. So we have ChromaDB, Pinecone, and there are other database as well you can use to store your embeddings. So to create these chunks into vector, we will be using this class vector store index from Llama index. So we will import it here. And then what we are doing, we are passing our document. So this is our document that we have loaded, the entire text. And then in transformation, we are saying that we want to break down this entire document into chunks, and chunks are based on this text splitter that we have generated here or that we have created here. So it will break down this document into this text splitter. And once it creates these chunks, these different chunks, then we will convert these chunks into numbers using our embedding models that we imported here in this embedding. So using this embeddings class, we will convert these chunks into embedding. And finally, we will have this our document into chunks and then numbers. So now we have our document as a numbers that we can pass to our LLM. So once you have created that, now you have to just create a query engine. So what to create a query engine, we are storing this result into this index, in this object index. Now what we will do, we will call this function as query engine on this index, on this text we have. And then inside this, we will pass our LLM, the model that we are going to use to query our data. And we are using Llama 3.1, this LLM that we have saved here. So let me run this first for you. So this is for Hugging Face embeddings, and this will import the embeddings for us. And after that, I will also run this sentence splitter and also this text splitter, and then this one, and then creating this index, and then creating query engine. Now, once you have this query engine, you can start asking question to your document. So as this document is about an essay from Paul Graham, so the author of this essay is Paul Graham. So now the first question that I am asking is, who is Paul Graham? And if I run this, so I will get the output. It says that Paul Graham is a writer, programmer, and entrepreneur who has worked on various projects, including Web, a company that was later acquired by Yahoo, and Y Combinator, a startup accelerator. He is also a painter and has written numerous essays on a wide range of topics, which have been published online and later reprinted in a book called Hackers and Painters. So now you can ask another question. So what I will do, I will just copy this from here, paste it here, and let's ask some question from this response. So it says that he's also a painter and has written numerous essays on a wide range of topics. So let us ask, what are the essays written by Paul Graham? And let us execute this code. Paul Graham wrote essays on a wide range of topics, including the implications of the web, the nature of publishing, and the importance of working on things that aren't prestigious. He also wrote about his personal experiences, such as his work on Lisp and his decision to start a new dialect called Arc. Additionally, he wrote about his life, including his decision to move to England and his experience as a parent. Okay, so we got a response for this. Now let me copy this and paste it again, and let me ask some other question. What did or what did the author Paul Graham do growing up? The author Paul Graham spent time in Italy as a child, where he lived at Pizza San Felice 4 in Florence. He walked to the Accademia, passing notable landmarks such as Pitti and so on. So you see, we got a response for this. And maybe I can ask some stupid question. Who is Paul Graham? Okay, I've already asked this question, and I can ask where Paul Graham is from. Paul Graham is a British citizen by birth. Okay, so you see that I get all the response that are present in the text file. So I can ask any question and I will get the response. Maybe I can even ask something I can take from here. If I find something relevant. This I see something YC logo. Let me ask, what is this YC logo? What is the YC logo? The YC logo is not explicitly mentioned in the provided context. However, it is mentioned that the author of the essay, who is also the founder of YC, has to deal with a lot of stress related to Hacker News, which was a part of YC. So yes, we have a very little information about this YC. We see something here. So we got a very good response that is not explicitly mentioned in the provided context because this is an essay about a lot of things, not about this YC. But however, wherever this YC was mentioned, we got this in the output. So you can see that you can create your RAG in few lines of code. You can upload your document and you can start asking your question. And once you have this RAG, you can create your chatbot. So it becomes very easy for you and you can proceed to the next steps and create some even advanced chatbots and things that you want to do with LLMs. So that's all I wanted to share with you all about the uh, RAG pipeline, how you can create it using framework Llama Index and the open source model LLM Llama 3.1. And whatever I have shown you, everything is free. You can go and you are free to do anything. It's free for, it's free. I mean, everything is free here. The framework, the LLMs, and even this text file, the sample text file. Now let's take some question and answer. If you have any question, please feel free to ask, and I'll be very happy to answer you.
Firstly, Amir, thank you for your great presentation. I hope everybody enjoyed as much as I did. For now, I see there's no questions, but we can wait a minute or two to see if somebody has a question.
Sure.
And yeah, I cannot turn my camera on because I don't know why. But yeah, okay, we can stay without camera just so we don't
Yeah,
switch
no
the
problem.
phones again.
No problem.
We have a question from Igor. He said, have you used Grook Cloud API, not locally installed Llama?
Yes, you're right. I have used this API key that I have shown. So this one I have used this API key. I have not installed it locally because if you install it locally, then your machine should be very powerful. It takes a lot of time to generate response when you install this locally.
Okay, Amir, thank you for your answer. And also, Igor, thank you for your question. Do you have any more questions?
You're welcome.
Okay, if we have no further questions, I would like to thank you, Amir, for participating in this year's DSC DACH and giving this amazing tutorial to all our attendees. Also, for the attendees, tomorrow morning, yeah, for now, this is the last session for the day and the last session of online part of this year DSC DACH. Tomorrow at 8:30 uh, is registration at the event. So be sure to be there on time so you get a badge. So yeah, I hope you enjoyed this whole day. And once again, Amir, thank you so much for participating.
Thank you so much for giving me this opportunity and
You're welcome.
sharing my knowledge with everyone. Thank you again. Thank you everyone for attending the session.
Yeah, see you.
See you. Bye.
Bye bye. Goodbye.
Goodbye.